Good morning guys, welcome to BJ's Online Academy Tutorial. Thanks for watching our videos online. Please, if you have not subscribed to this YouTube channel, please do wait to press the subscribe button and the notification bell in order to see all of our educative videos online. Please do wait to share this video with your friends, families, relatives and colleagues at home. Thank you and God bless you. Today I'm going to be considering the topic called resistivity. The topic called resistivity under the electricity, particularly the direct current. When you're talking about resistivity, resistivity is the ability of a material to hinder the flows of electric current. Resistivity is the ability of materials to resist the flow of electric current, that is the flow of electrons through them. And resistivity is very, very important in order to know how a materials will conduct electricity. And that's what we're going to be talking about today. We have resistivity for different materials. The resistivity of aluminium is different from the resistivity of copper, and so on and so forth. Now, mathematically, the resistivity can be derived when resistance. Resistivity can be defined when resistance is directly proportional to to L, and inversely proportional to to the area of the material. Now, from this relationship, we can derive our resistivity, the formula for resistivity. So we talk about when you combine this variation together, it becomes R is directly proportional to L multiplied by R inversely proportional to A. So in other words, we have R is inversely proportional to L all over A. Now, replacing this constant of proportionality with constant. Replacing this sign of proportionality with constant. So we have R equal to resistivity, which is rho, L all over A. Now, this is what we have when we replace our constant of when we replace our proportionality with a constant rho, where rho is the resistivity, where rho is the constant of proportionality, is equal to constant of proportionality called resistivity. Now, where the constant of proportionality is called is the constant of where rho is equal to the constant of proportionality called resistivity. Now, you can see that from R directly proportional to L and R inversely proportional to 1 over A, that is the area of the material. So by combining the variation together, which is the direct and inversely proportional variation, we get R equal to R is proportional to L over A. Then we have R equal to rho multiplied by L all over A. This is called rho in Greek in Greek, because this is a Greek alphabet called rho. Now from here we can make our rho the subject of the formula. So we have rho equal to RA, which is all over L. So this is the formula for resistivity. Mathematically, resistivity is equal to resistance multiplied by cross-sectional area all over L, where R is the resistance. Is the resistance of the material. R is the resistance of the material. The resistance of the material. We have the resistance of the material. We have R equal to the resistance of the material. We have we have A is the cross-sectional area. Cross-sectional area of the material given. This is the area, and L is the length of the wire or material, whatever the case. Material can be wire, can be anything that comes in mind. Now you have L equals to net of material measured in This one is measured in meter. This one is measured the resistance is measured in ohms, and the area is measured in in meter per second square. The SI unit is meter per second square. Now, most of us, especially when you are talking about wire, wire, the area of the wire is what? Is calculated by what? By the shape of that wire. And usually wire is usually calculated, is usually round in shape. The wire is usually, especially when you take copper wire or aluminum wire, it's usually was circular in shape. That's why most especially the question that always that's usually said by Jamb and why is usually based on wire, because wire is circular in shape. And whenever you wanted to calculate or to determine the area of of a circular wire, we use area is equal to pi r squared. That is the area of a circle. Area of the circular part. You have area is equal to pi r squared. And where r is equal to d all over all over 2. Now we are having r squared here. We have a here is equal to pi multiplied by multiplied by d all over 2 all square. So in other words, we have another area in terms of d. So if we replace this r equal to d over 2 into this formula, we have pi times d over 2 all square. So the formula here is going to be pi d square all over 4. So whichever the case might be in question, when you are given r, you use this formula pi r square. But when you are given d, you use a equal to d by d square all over 4. Whenever you are given the diameter, we use pi d square all over 4. Whenever you are given the radius of the wire, you use pi r square. So these are the formula you need to note. When resistivity of the material is was asked to be determined. Now, here's the formula that you need to know about resistivity, and know that one of the factors that resistivity depends on is temperature. The higher the temperature, the higher the resistivity of a material. You can ask the factors affecting factors that can affect resistivity of a material. Factors that can affect the resistivity of a wire. Factors that can affect the resistivity of a material. Factors that affect the resistivity of wire or material. We have the first one is the temperature. The higher the temperature, the higher the resistivity. Now, the higher the temperature, the higher the resistivity. So it means when you increase the temperature of any material, the resistivity has tendency to be increased. That is the higher the resistance to flow of electric current. Number 2 is the alloying. When you introduce alloying is just mixture of 2 or more metals to achieve and improve properties. Now, but when you introduce some metals into some materials, it causes the resistivity to increase. So introducing other metals into a material might cause that materials to have an increase in resistivity. We have alloying, we have the adding, the cold adding. When the material is adding, also the resistivity might also be whenever the resistivity might also increase, and so on and so forth. But these are the major factors. We have the alloying, the adding, and aging. When material is aging, it's also causes the resistivity to be increased. Now let's go. Now here are some Waec and Jamb question on resistivity. Number 1 question says an aluminum cable of diameter 4 times 10 to the minus 3 meter and resistivity 3.0 times 10 to the minus 8 Newton per meter has a resistance of 21 ohms. Calculate the length of the cable. Now look at the question very well. An aluminium of diameter 4 times 10 raised to power minus 3 meters. So question number 1, we have solution to Jamb and Waec questions. And Waec questions. Now, especially Waec question. Now we have number 1. says that an aluminum cable of diameter what? Of aluminum cable of diameter 4.0 times 10 raised to the power what? Minus what? Minus 3 what? Meter. Minus 3 meter. That's the what? The diameter. And the resistivity rho. The resistivity rho is given as what? 3.0 times 10 raised to the power minus what? Minus 8 Newton per Newton meter. Now note that the unit of resistivity, the unit of resistivity is what? Because from the formula here, we have resistance meter square. You can derive the what? From here now, the unit of what? Of resistivity from this formula is given as well. You know the unit of what? Of R is what? Ohm. The unit of R is what? Is ohm. The unit of area is meter what? Square. And the unit of length is what? Is meter. So this meter will cancel one of the meter here. So the unit of resistivity, so the SI unit, or the unit of resistivity, the unit SI unit of what? Resistivity is what? Newton what? Newton ohms. So that's the unit. It's not that the unit of what? Resistivity is what? Is Newton what? Meter. And also they might ask you to what? To also calculate the what? The conductivity of a material. When I'm talking about the conductivity of a material, it means the reciprocal of the what? Resistivity. And conductivity is the reciprocal of what? Of resistivity. So if I want to calculate the conductivity of a material, I will have to find the reciprocal of what? Of the resistivity of the material. So in other words, conductivity here, conductivity is the reciprocal of what? Of resistivity. So conductivity is represented by what? Kappa. Kappa, something like what? K like this, but we call it kappa in what? In Greek letter. So kappa is given as what? 1 all over what? Resistivity. Kappa is given as what? 1 all over what? Resistivity. Meaning that the unit will be what? 1 all over Newton ohm. So the unit of what? Of resistivity. Note that this is the formula of resistivity. So the unit of resistivity will be what? Newton meter per what? Per ohms. So this is the unit of what? Resistivity, but this is the formula for what? Resistivity. Kappa is equal to what? 1 all over what? Resistivity. Please note that. So that's conductivity for you, because in the question you might have to what? To calculate the conductivity of a material. Just get the resistivity and find the reciprocal. And reciprocal means 1 all over the answer that you what? Obtain. Now going back to the solution of what? To the solution to Jamb and Waec question. Question 1 says an aluminium of cable diameter what? 4 times 10 raised to the power minus 3. So the diameter is what? 4 times 10 raised to the power minus 3. And what? And the resistivity, which is rho, is 3.0 times 10 raised to the power minus 8 ohm meter. So that's that for the resistivity. And as a resistance of what? And as a resistance of R equal to what? 21 what? Ohm. That's the resistance of what? 21 ohm. Calculate the length of the wire. Now look at this. We are asked to calculate the length of the wire. Calculate the length of the wire. Calculate the length of the wire. Here we are asked to calculate the length of the wire. So, but you know that the resistivity itself is what? You know that, recall that resistivity is equal to what? Resistance multiplied by cross-sectional area of the material all over what? L. So from here you can easily make what? L subject of the what? Formula. So how do we make L subject of formula? Therefore, we have what? Therefore, we have L to be equal to RA, just cross multiply. So we have what? Change this one. So L equals to what? RA all over what? Resistivity. So now, so therefore we have L is equal to what is our what? Now look at this. We need our area for us to get what? Our resistivity. And we are told that a cable, aluminum cable, you know, aluminum cable look like this. Aluminum cable look like it's black. It has a black color. So aluminum cable is what? Is insulated by what? By a rubber which is circular in what? In shape. Is circular in what? Is circular in shape. So that's why the area of what? Of the cable. The area of the cable will be given as well. Let's calculate the area of the cable. The area of the cable will be given as well. Since we are given in diameter now, and what the cable is what is circular in shape, so A is equal to what? Pi. I'm going to use what? Area equal to what? Pi d square all over what? All over 4. And let's quickly calculate the area before substituting here. So let's quickly calculate the area here. So area is given as what? Area is given as what? 3.14 as our pi. 3.14 multiplied by, ensure that the unit is meter, which is a meter already. So 4.0 times 10 raised to power minus what? Minus 3 meter square. Remember to put square there. Square. So all over what? So don't forget the meter also carry what? Square. So we have 3.14, which is what is our pi, multiplied by the diameter, which is 4.0 times 10 to the power minus 3 all squared. We apply this formula all over what? All over 4. All over 4. So from here now we have what? We have our area to be equal to what? Now, and multiply this one is 3.14 to 14 times what? 16 multiplied by, now this is 4 squared with 16 multiplied by what? 10 raised to the power minus what? 10 raised to the power minus 6, because this one we multiply this by 2, so all over 4. All over 4. So this one cancels out like this. 4 here, 1, 4 here, 4. So when you multiply this one, you are going to have what? 12.56 times 10 raised to the power what? Minus what? 6 squared. So that's our area for that. That's our area for that. Now let's calculate the length here now. So I'll quickly make use of this space to calculate our what? So here now, to calculate our length for this question here, it's going to be what? R L. It's going to be what? L, following the formula, L equal to what? R A now, all over what? All over rho. So we have what? Now what's our R? Our R is 21 ohms. 21 ohm multiplied by what? 21 ohm multiplied by 21 ohm multiplied by what? Area, which is what? 21 ohm multiplied by area, which is 12.5 times 10 raised to the power what? Minus what? Minus 6 meter square. Meter square. All over the row, which is the row. Well, our row here is what? 3.0 times 10 raised to the power minus 8. With this now, we can get our what? We can easily get, so 3 here 1, 3 here, we have what? 7, have 3 here 7, so we have 7 times 12.56, we are going to have what? 87.92. So 87.92 times 10 to the power minus 6, then this one goes up, become plus. So this one we are doing is because Jamb, you are going to be using calculator, and that calculator in Jamb does not have exponential. So you have to know how to what? How to do it arithmetically without what? Without using scientific what? Calculator. 7.92 times 10 to the power what? 2. Now if you move this one to standard form, that is, you move it to what? To standard form. So this point, this decimal point will come here. It will now be equal to what? 8.792 times 10 to the power 1 times 10 to the power what? 2, making what? 8 point, approximately this one now. So they took one decimal place here that we are doing here. So this one goes 8.8. If I approximate this one will go 8.8 times 10 to the power 1 plus 2 to go to the power what? 3 meter, because the unit is what? The unit is not meter because it is length. So that's that about number 1 question. So now let's go into what? Into number 2 question. Question number 1 is what? Option what? Option B. Now, question number 2 says a wire of cross-sectional area 0.60 meters squared. So solution here we have what? We have a wire of cross-sectional area. The wire of cross-sectional area 0.60 millimeter what? Millimeter square has a resistivity of what? The resistivity is what? 7.2 times 10 raised to the power minus what? 7 Newton ohms. You can see that this one is what? So this is what? Ohms meter. So the resistivity is 7.2 times 10 raised to the power minus 7 ohm meter. And this one is what? Area is equal to 0.60 millimeter square. So it means that we have different units entirely here. We have millimeter square here, we have meter here. So now take note of that. We have calculate the length of wire that will have a resistance of what? The length of wire that will have a resistance of R equal to 3 ohms. We have to calculate the length of a wire that will have a resistance of 3 ohms. Now the length of the wire is a meter, and now we have the area in what? A millimeter square, meaning that we have to convert the millimeter square to what? To meter square. Now how do you convert? How do you convert? Look at this. We know that what? 10 millimeter is equivalent to what? Is equivalent to 1 centimeter. And we know that 100 centimeter is equivalent to what? 1 millimeter. 10 millimeter is equal to 1 centimeter. 100 centimeter is equivalent to 1 meter. So therefore, 1000, if you multiply this one together, this will be 1000 millimeter. 1000 millimeter is equal to 1 what? Meter. If you recall, from 10 millimeter is equal to 1 centimeter. 100 centimeter is equal to 1 meter. Definitely 1000 millimeter is equivalent to what? 1 what? Meter. Now if 1000 millimeter is equivalent to what? 1 meter, meaning that what? Which is that we can write this 10 millimeter as 10 raised to the power what? 3 millimeter equal to 1 meter. So, and we are taking millimeter square to what? Meter square now. So we have to square this millimeter. So to square this one, so that we know the value of what? Millimeter square that will what? That will give us 1 meter square. So when you square this, we have 10 raised to the power 6, because 2 times 3 is 10 raised to the power 6 millimeter square equal to 1 square meter square. 1 square is 1. So we have what? So if this 10 raised to the power 6 millimeter square is equal to 1 meter square. So 10 raised to the power 6 millimeter square is equivalent to what? 1 meter square. So definitely now we can now put your 6.6 millimeter square and take it to what? Take it to meter square. And how do you do that? You cross multiply. So when you cross multiply, this one will be 0.6 millimeter square multiplied by 0.6 millimeter square multiplied by 10. Okay, multiply by, you cross multiply. Look at this. You multiply this together, then you divide with this. So 0.6 meter square multiplied by what? 1 meter square all over 10 raised to the power 6 millimeter square. Please, I'm teaching this in order to know how to convert. So now this one cancel out this. So 0.6 times this. So it will just 1. 0.6 times 1 to be what? 0.6 meter square all over 10 raised to the power what? 6. It means that 0.6 times 10 raised to the power, when this one comes out, minus 6 meter square. So when you take it to center for, you have 6 times, this one will move 1 time. So 6 times what? 10 raised to the power minus 1, because it's moving forward, times 10 raised to the power minus what? 6 meter square. So we have what? 6 times 10 raised to the power minus 7 meter square. So that is what? That is your what? That is your area in meter square. Please, if you don't know anything at all in this conversion, note that 10 raised to the power what? 6 millimeter square is equivalent to what? 10 raised to the power what? 6 millimeter square is equivalent to what? 1 meter square. Please note this. So that whenever you are given what? An area in millimeter square, you can divide by 10 raised to the power what? 6. You can divide by 10 raised to the power 6, or you can multiply by 10 raised to the power minus what? 6. I hope I'm not convincing you. If you have any questions concerning this, please drop it in the comment box, so as to know how to what? Tackle it together once again. So this is what? Now this is the area in meter square. Now we've gotten the area in meter square. The question says we calculate what? The length of wire. We know that from resistivity is equal to what? RA all over length. We can easily make L solve the formula. And when we make L solve the formula, what do we have? We have L equal to what? RA all over what? Resistivity. All over resistivity. So what's our value now? When you substitute our value now, your resistance is 3 ohm multiplied by what? 3 ohms multiplied by the area, which is what we just converted now, 6 times 10 raised to the power what? 6 times 10 raised to the power minus 7 meters squared all over resistivity. Resistivity is what? 7.2 times 10 raised to the power minus what? 7. So what do we get now? Look at this. This one definitely we cancel out this. So 3 times 6 we have what? 3 times 6 we have 18 all over 7.2. 18 over 7.2 will give you what? 18 over 7.2 will give us what? 2.5 meter. 2.5 meter. So you can add 0 to it if you want to. 0, 2.50 meter. So that is 2.50 meter is the answer for our length. So that is option what? Option B. Question number 3 says that if a metal wire 4 meter long and cross-sectional area 0.8 millimeter square has a resistance of 6 ohm, find the resistivity of the wire. We are told that a metal wire of 4 meter long. So now question number 3 says that a metal wire of what? 4 meter long. Of 4 meter long. Then cross-sectional area of what? Cross-sectional area of 0.8 millimeter what? Square. Cross-sectional area has been given as 0.8 millimeter square and has a resistance of what? Resistance of 6 ohms. Resistance of what? 6 ohms. We are asked to calculate the what? Find the resistivity of the wire. The resistivity of the wire is to be determined. Now, what do we use? What's the formula for resistivity? You recall that resistivity is equal to what? Recall that resistivity is equal to resistance multiplied by what? Cross-sectional area all over what? Length. But mind you, this area here is what? Is given a millimeter what? Millimeter square, and the length is 4 meters. So we have to convert the millimeter square to what? To meter square. And we are told in the previous word, in the previous example, that 10 raised to power what? 6 millimeter square is equivalent to 1 meter what? Square. Please don't forget about that. So we have what? 0.8 millimeter what? 0.8 millimeter square. We now do what? Because multiply 0.8 millimeter square multiplied by 1 millimeter square all over 10 raised to power 6 millimeter square. Definitely this one will cancel out. So we have what? 0.8. Now this one will comes up. When this one comes up, it is 10 raised to power minus 6 meter what? Meter square, because this one is 0.8 times 1, so it is 0.8 meter square times 10 raised to power minus 6. So if you take this one to standard form by moving this one to the left hand side, so when you move it to the right hand side, you have what? 8 times 10 raised to power. Now this one is minus 1 plus minus 1. It will become 10 raised to power 10 raised to power minus 7. So this one, when you move this one, it is minus 1 plus minus 6. It means what? 8 times 10 raised to power minus 7 meter square. Meter square. So this is the what? This is the area in meter what? Square. Now substituting this value now inside what? Substituting the value inside the formula, we have what? The resistance to be what? 6 ohm multiplied by the area, which is what? 8 times 10 raised to power minus 7 meter what? Square. Area in what? Note that this is the area in what? In meter what? A meter square. A meter square. So now a meter square. So we have the resistance multiplied by the area 8 times 10 power minus 7 meter square all over length. What is your length? Length is 4 what? Meter. Length is 4 meter. So 4 here 1, 4 here 2. We have 2. So 6 times 2 here we have what? 12 times 10 raised to power minus 7 meter square. So minus 7 meter square. So when you take this one to standard form, that is it's taken to standard form, whereby the number will be between 0, and what? And 10. So when you take this one to the standard form, when you move this one from here, it will to the 1.2, it moves towards the what? Left. That is positive. When it moves towards the right, that is what? Negative. Since it's moving towards the left, that is plus 1. So we have what? 1.2 times 10 to the power 1 times 10 to the power minus 7. So, and this is the same base. So 1 plus minus 7 will be what? 1.2 times 10 to the power minus what? 6. Now the unit of resistivity is what? Ohms meter. This is not Newton. 1.2 times 10 to the power what? Minus 6. And the unit of resistivity is what? Is ohm per what? The ohm meter. Ohm meter. The unit of resistivity is what? Ohm meter. Please let's note that. So that's that 1.2 times 10 to the power minus what? 6. 1.2 times 10 to the power minus 6 is the way of the answer here. So the answer is what? Is option what? C. C. So question number 4 says that a conductor has a diameter of 1.00 millimeter. A conductor has a diameter of 1.00 millimeter and length 2.00 millimeter. Now, a conductor has a what? A diameter of 1.00 millimeter and what? And a length of what? A length L is equal to what? 2.00 millimeter. Now, if the resistance of the material is 0.1 ohm, the resistivity is what? If the what? Material has what? Resistance of 1.0 what? Ohms. So what is the what? What is the resistivity? The resistance of 0.1 ohm, 0.1 ohm. If the resistance is what? Is 0.1 ohm. What is the resistivity? The resistivity is what? Will be what? Unknown, Abi. Now, how do we go about it? The resistivity is unknown. So how do we go about this? Now, we are told that what? The diameter of a what? Of a wire is 1.0 millimeter. The length is 2.0 millimeter, and the resistance is what? 0.1 ohms. Find the what? Resistivity. Now, you can see everything here is in millimeter. The length here is millimeter, and what? And the diameter here is in millimeter. So I'm going to take it to what? I'm going to take it to what? 2 meter. But we know that on 1000 millimeter is equivalent to what? 1 what? Meter. So we divide by what? 1 what? We divide by 1000. So 1 millimeter now is equivalent to what? 1 all over what? 1000 what? Is equal to 1 over 1000 meter. That's just it. So by simply cross multiplying, we have 1 millimeter equal to 1000 what? Meter, which is same as 1 times 10 to the power minus what? 3 meter, because it's 10 to the power 3. And the same thing is applicable to what? To the length. So the diameter here is what? 1 times 10 to the power minus 3, which is same as 10 to the power minus 3 millimeter. So now the same thing applicable to what? To 2.00 millimeter. So 2.00 millimeter divided by 1000 without which most of our time, we have what? 2 times 10 raised to the power what? Minus what? 3 meter. So meter. This is 10 raised to the power minus 3 meter. This one is what? 2 times 10 raised to the power minus 3 what? Meter. So now, if that be the case, so the length is 9 meter now, and what? And the diameter is 9 what? A meter. So now we can calculate what? The resistivity. And we know that the resistivity itself is what? Is RA all over what? All over L. But the area here, you have to look for the area here, because area is not given in the question directly. So since the what? Since the conductor has diameter, so we know that the area will be what? Pi d square all over what? 4, which means that 3.142 multiplied by what's your d? Your d here is what? Is 1.00 millimeter, which has been converted to what? 10 raised to the power minus 3 meter. So 10 raised to the power minus 3 all what? Square all over what? 4. So 4 divided by 3.142, I'm going to have 0.7855 times 10 raised to the power. Now look at this. 10 raised to the power minus 3 raised to the power what? Minus what? 10 raised to the power minus 3 raised to the power 2 is minus 3 times 2 is 10 raised to the power minus 6 meter square, because it is area that we are looking for here. Area is equal to 0.87855 raised to the power minus 10 raised to the power minus 6 meters square. So if we take this one to the standard form and move this one to the what? To the right, it becomes minus 1. So it will be same as what? 7.855 times 10 raised to the power minus 1 times 10 raised to the power minus what? Minus 6. So our area here to be 7.855 times 10 raised to the power minus 7 meter what? Square. So now substituting the value into what? Into this now, we have what? The resistivity to be what? What's your R? Your R here is what? 0.1 multiplied by what? 0.1 times what? Area, which is what? 7.855 times 10 raised to the power minus 7 times 10 raised to the power minus 7 all over what? All over what's your what? What's your L? L is what? L is what? 2.0 millimeter. 2.0 millimeter, which has been converted to what? 2 times 10 raised to the power minus what? Minus 3. So 2 times what? 2 times 10 raised to the power minus what? 3 what? Meter. So don't forget that this is millimeter that has been converted to what? To meter. So now to millimeter now we have what? Resistivity to be what? 0.1 times 7.855 divided by 2 give you 0.3927 times 10 raised to the power minus what? 7. Now when this one comes up, it becomes what? Plus what? 3. You can use your calculator, but when it comes to what? Law of indices, you might not be able to use your calculator in Jamb. So that's why I'm teaching you what? The mathematical aspect of it, so that you can be able to do it in Jamb as fast as possible. So we have what? This one is what? Is 0.3927 times 10 raised to the power minus what? 4. Minus 4. Now because minus 3 plus 3 minus 7 plus 3 will give minus 4. So when you move this one back to standard form, or you move it back to standard form, you're moving with minus 1. So the final answer here will be what? The final answer here will be what? 3.927 times 10 raised to the power. Now because you have moved to 1 in the negative or in the right hand side to be negative minus 1. Minus 1 minus 4 will be what? Minus 5. Now we are calculating resistivity ohm per meter or ohm meter. So please, that's the unit of resistivity. So that's the answer for that. 3.927 times 10 to the power minus 5 meter. So when you approximate this one now, you are going to have what? When you approximate this one will be what? This one will be, when you approximate it to the what? To the 2 decimal place, 3.93 times 10 raised to the power minus what? 5 watts Newton meter. So Newton meter. So the final answer is 3.93 times 10 to the power minus 5 Newton watts meter. So that's option what? Option C. So option C, number 5. So I told that the resistance of a piece of wire, of length 20 meter, the resistance of a piece of wire of length 20 meter and cross-sectional area 8 times 10 to the power minus 6 meter square is dash. The resistance of a piece of wire of length The length of the wire is 20 meter, and the cross-sectional area A is equal to what? 8 times 10 to the power minus 6 meter square. So that's the area. What will be the resistance? Because we have to talk about the resistance of the wire of length 20 meter and the cross-sectional area of 8 times 10 to the power minus 6 meter squared is dash. So we are looking for the resistance. The resistance here is unknown. Why the resistivity given to us here? The resistivity of the wire is given as what? 4 times 10 to the power minus 7 Newton ohms. Now look at this very well. All the units here are in meter, and resistance is unknown. So if we are to look for the resistance, we have to recall the fact that resistivity is equal to RA, that is all over what? L. And from here we can make resistance formula. So this is R by cross multiplying now and dividing both sides. We have R is equal to resistivity times this one. It will be resistivity times length all over area. So area. So R now we now be what? Resistivity times what? Length all over area. What's your resistivity? 4 times 10 raised to the power minus 7 multiplied by what's your length? The length is 20. And what's your area? Area is 8 times 10 raised to the power minus what? 6. Now, with that, how do we go about this? So, this is 4 here, 1, 4 here, 2, 2 here, 1, 2 here, 10. So, we have 10 like this. So, this is 10 raised to the power 1, don't forget. Now, R here is going to be what? 10 raised to the power minus 7 multiplied by 10 raised to the power 1. Now this one come on multiplied by 10 raised to the power positive 6 because it's going to be positive when it comes up. So R is equal to 10 raised to the power minus 1 plus 1, 10 raised to the power minus 7 plus 1 plus 6. So definitely we have what? Minus 1, 10 raised to the power minus 7, 10 raised to the power minus 7 plus what? 7. So minus 7 cancel minus 7, so we have 10 raised to the power 0, which is what? R is equal to 10 raised to the power 0 is what? 1 ohms. So the answer is what? 1 ohm. So law of indices, anything raised to the power what? 0 is 1 ohm. Now we have come to the end of today's lesson. Please remember to what? To subscribe to this YouTube channel, like the videos, and share the videos with your friends. See you next time. God bless you.